Okay, we're going to be going over topics for meet 3. So I'm going to go over the tryout problems. And we're going to go in order of difficulty. So we're going to start with the easiest event is event 5. Operations with polynomials. Now I'm assuming we know how to add, subtract, and multiply polynomials. Although I don't know if we can assume that. So how do you multiply like a binomial times a trinomial? Okay, 2x squared plus 3x plus 4. You take the first term, distribute it, take the second term, distribute it. That's basically how you do it. Okay, but what about dividing? Okay, like what if you have 2x cubed plus 3x squared plus 5x plus 7, and you have to divide that by, say, x plus 1. Well, you would do long division. So let's review how to do long division. X goes into this how many times? 2x squared. And then you multiply that times the divisor, 2x cubed plus 2x squared. And then you subtract and you get x squared plus 5x plus 7. And then you go x goes into that how many times? X. And then you multiply that times the divisor, which is x squared plus x. And then you subtract and you get 4x plus 7. And then x goes into 4x how many times? 4. Multiply that times the divisor and you're going to get 4x plus 4. Subtract. When the degree of this is smaller than the divisor, we call that the remainder. This is called the dividend. This is the divisor. This is the quotient. That's the remainder. So when you divide that by that, the result is the quotient, this, plus the remainder over the divisor. That's what you get when you long divide. Now, of course, we have a shortcut now. For those of you who haven't taken Algebra 2 yet, there is a shortcut for long division. It's called synthetic division. So I'm going to teach you how to do that now. This comes in handy. So you write down the coefficients of the dividend, put a box here. Now, when you do synthetic division, you're dividing by x minus a number. So x plus 1 is the same thing as x minus negative 1. So you put negative 1 in the box. And it's very mechanical, very simple. Drop the first number down, and then the rest is just multiply and add. So you multiply this times this, and you get negative 2, add. This times this, multiply. Put it here, add. This times this, put it here, add. So what do you think this stands for right there? Those are called the depressed coefficients. That will stand for the coefficients of the quotient here. So this stands for 2x to the square plus 1x plus 4. This is the remainder plus 3. And the divisor is x minus the number in the box, which is x plus 1. That's called synthetic division. Let me just make sure this thing is going. Yes. Now on the tryout problem yesterday, there's two ways you could have done it. One way is just long divide, right? So x squared, if this is going to be a factor of this, ax cubed plus bx squared plus cx plus 12, 0x, I'm sorry, 0x plus 12, then that means the remainder has to be 0. Okay, so one way is to do long division. So x squared goes into this how many times? Ax, and then you multiply this times the divisor, which is ax cubed plus 5ax squared plus 6ax, and you subtract. So this minus this will be b minus 5ax squared, and then this minus this is plus negative 6ax plus 12. And then x squared goes into this how many times? b minus 5a. So that times the divisor, you will get b minus 5ax squared plus 5 times b minus 5ax plus 6 times b minus 5a. And then if you subtract, x squareds cancel out, and then this minus this is going to be negative 6a minus 5b plus 25a x, plus this minus this is going to be 12 minus 6b plus 30a. This is the remainder here because the degree of this is smaller than the divisor. This is degree 1, this is degree 2, so that's the remainder. And if it's going to be a factor, the remainder has to be 0. So if this is the remainder, the only way this can be 0 is if the coefficient of x is 0 and the constant is 0. So this has to equal 0, which is what? 19a minus 5b, you gotta equal 0. And this also has to equal 0. So 30a minus 6b plus 12 is equal to 0. And then you just solve these two equations, two variables, and that's how you find a and b. So that's one way of doing it. The other way is using the remainder theorem. Did you guys notice that this can be factored as x plus 2 times x plus 3? Okay, which means, of course, what? This, both of the, if this is a factor of that, that means both of these are also factors of that. And if something is a factor, that means the remainder is 0. So one way is you could do synthetic division with this, and you could have something like this, a, b, 0, 12. You can do synthetic division with either negative 2 or 3. Put it here, and then you set the remainder equal to 0. Okay? Probably you got to do both. However, if we use the remainder theorem, which is, the remainder theorem says, okay, let me write this again. The remainder theorem says, if you do synthetic division with a number, then the remainder that you get here is the same thing as taking this number and plugging it in to the polynomial. So, instead of doing synthetic division, I mean, which is fine, why not just take the negative 2 and plug it into this? Okay, so if I take negative 2 and plug it into the dividend here, you're going to get negative 8a plus 4b plus 12, and we want the remainder to be 0 because it's a factor, right? And notice you have one equation, two variables, so you need another equation. So you do the same thing with negative 3. If you plug in negative 3 into here, you can get negative 27a plus 9b plus 12. That has to equal 0 because we want the remainder to be 0. And then you can just solve these two equations, two variables, and you're going to get the same answer. So for those of you who don't know synthetic division, right there, I just taught you how to do it. Okay, the next easiest event is the word problems, event 3. Okay, this one I think I'm just going to show you how to set up the tryout problem, event 3. Okay, because a lot of you did not set it up correctly. You got to know the most efficient way to set up these rate times time equal distance problem. Rate times time equal distance, which of course means time equals distance over rate. Now the reason why I'm doing that is because they tell you what the total time is, right? She went up the river and down the river in 16 hours. So the time to go up plus the time to go down the river, so the time to go up plus the time to go down the river is equal to 16 hours. Now, what was the time it takes to go up the river? Well, it's going to be the distance divided by the rate. Well, what is the distance to go up the river? 90. And you divide that by the rate. Well, she can row 14 miles per hour in still water, and if she's going upstream against the current, then wouldn't her rate be 14 minus x, if we call x the current rate? Now, coming downstream, then what was the distance? 90 over, divided by rate, which is 14 plus x. And then you just solve that equation. The key is the setup. All you have to do is multiply both sides by the LCD, right? Okay, I think you can take it from there, but this is the fastest way to set up a problem like this. Some of you did it some bizarre, strange way, which is okay, but this is just much more efficient. Okay, next, event 2. Geometry. Now, you still have to know all your similar triangles, theorems, and stuff like that. So if you weren't in, if you didn't go to meet 2, I would say open up download the notes for meet3, right? Because you guys have access to the website, and we have all the theorems there. But some important ones, especially with right triangles. When you have a right triangle and you drop the altitude to the hypotenuse like this, these have to be at your fingertips, people. And then this is D, E, and F. Then A squared is equal, this squared is equal to that times that, which is E times C. B squared, this squared is equal to that times that, which is F times C. D squared, this squared is equal to that times that, which is E times F. And then finally, A times B is equal to C times D. This times this equals that times that. And that comes from the area of the triangle, right? 1/2 base times height equals 1/2 base times height. These have to be at your fingertips. So if you knew that, and of course the angle bisector theorem, if you have a triangle and you bisect this angle right here, then A over B equals C over D. There is also another theorem there, but I'm going to let you look at the notes for that because I don't want this getting into enemy hands, because anybody can watch these videos once it's on the internet. Okay, so in this problem, I think now it's pretty easy now. Triangle ABC has a right angle at B. Point D is on AC, so that BD is perpendicular right there. So right there, you know you're going to use these theorems right here. This is D. BE bisects angle ABD. This would have been a better problem if this bisected this angle, angle ABC, but don't worry, I'll give you that at the marathon. So this is BE bisects this angle, so this angle equals that angle. So immediately, once you see bisected angle, you know you're going to use the angle bisector theorem. This is 4, 3, and therefore this is 5, which means you need to know your Pythagorean triples, yeah? 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25, 9, 40, 41, 11, 60, 61, and so forth. And then some strange ones, like these. Oh, you better look at the notes. I don't want this getting into enemy hands. But 12, 35, 37, 20, 21, 29. Make sure you know your Pythagorean triples. Uh-oh. It's spreading like wildfire now. Okay, what are we trying to find? Find the length of DE right here. What is this? Okay, what do we know? Well, we know that this, that's the problem. This is the angle that's bisected. Okay, so let's figure out some sides first. Okay, so what if I want to figure out this right here? Okay, why do we call that M? Then using these theorems over here, right? Because you have a right triangle and you draw this down to the hypotenuse. 3 squared is equal to M times the whole thing. So that's 5M. So therefore M is equal to 9/5. So we know this is equal to 9/5. I'm not sure if we're going to use it, but I'm just showing you how the theorem works. And then what about AD? What do we call ADN? Okay, like here. Ooh, look at N. So 4 squared is equal to N times the whole thing. So that's 5N. So therefore N is equal to 16/5. Of course, we could have just subtracted it from 5, right? But I just wanted to show you how these theorems work. Okay, now, our goal is to find this. Well, what about this? Why don't we call this one P right here? Well, according to this theorem, P squared is equal to what? M times N, which is 9/5 times 16/5, which is 144 over 25. So P is equal to 12/5. Of course, you also could have gone this times this equal that times that. You get the same thing, right? But I'm just showing you the theorems here. Okay, so now we know this is 16/5 right here. So if you want to find this x, then wouldn't this be 16/5 minus x, since the whole thing is 16/5? Yes. So since this angle is bisected, look how easy this problem is. You just go this over this equals that over that. So 4 over 16 fifths minus x is equal to 12 fifths over x, and then you just cross multiply and solve. So this problem wasn't very difficult at all if you knew your theorems. Okay, so that's geometry. Okay, next one is event 1, radicals. Now, even though you're not in this event, you can learn something by watching this. Okay, the problem on the tryout is kind of, it's not that difficult. This would be on the easy side. Basically, you just have to know your rules of exponents for this one. Okay, so the first thing I would notice is, this is like, what do we factor out of 2 to the x from these two terms? What, if I factor out a 2 to the x, what's going to be left? 4 times 2 minus 3. And that's equal to, let's move this on the other side. This is just one way of doing it. And then of course 8 minus 3 is 5, so 2 to the x is equal to this divided by 5. If you divide this by 5, what is that? 2048? And then now look how easy this is. 2 to the what power equals that? Come on, 11. Right? Because everybody knows 2 to the 10th is 1024. Yeah, a little bit easy. Okay, but the problems that are typical in this event, okay, first of all, simplifying radicals. Like if you have a radical, well, you guys know how to do this. Let's just say you have something over root 3 minus root 2. To simplify that, you would multiply top and the bottom by the conjugate of the denominator when you have square roots. Like that. So that's easy. Okay, but what if you had something like this? What if you have 2 over, what if you have 3 radicals in the denominator? Root 2 plus root 3 plus root 5, say. You know, how do you figure out the conjugate? Well, you got to group it. So why don't we group it like that, see? So then you would multiply top and bottom by the conjugate of this, which is root 2 plus root 3 minus root 5. Root 2 plus root 3 minus root 5. And that's how you do it when you have 3 terms. And then you got to be able to do it with cube roots. So what if you had something like this? 3 over the cube root of, that's not cube root of 4 minus the cube root of 2. You just make up something. How do you simplify this? Because remember, no radicals in the denominator. You can't multiply by conjugate when you do cube roots. You got to use the sum and difference of cubes. So you need to know this. A cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. And a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. That's what you need to know. So if you want to simplify this, see, this is like the a minus b. That's this thing right here. You have to multiply this to get the difference of cubes. So you need, so if this is a and this is b, you got to multiply by this, which is top and bottom by this squared cube root of. Now, in this event, instead of using radicals, like if I were doing the problem, I would just, because this is like 4 to the 1/3 and that's like 2 to the 1/3, I would use fractional exponents, but that's just me. So this squared would be 4 to the 2/3 plus this times this, which is the cube root of 8. Oh, that comes out nice, 2, plus this squared, which is 2 to the 2/3. This is what you have to multiply top and bottom by. Oh, 2/3. And then if you do that, see, the top is simply going to be 3 times 4 to the 2/3, which is the cube root of 16, which is 2 cube root of 2, right? Plus 2. 2 to the 2/3 is like the cube root of 4. That we can leave. And then when you multiply this times this, see, you have a minus b times a squared plus ab plus b squared. You get a cubed minus b cubed. So if this is a cubed is 4, and if that's b cubed is 2. And that's how you get rid of the radical in the denominator when you have cube roots. Yikes! Well, if you have more than one term. And another problem, typical problem that comes up is you have to find the square root of a square root. Like, how do you simplify this? simplify the square root of 52 minus 30 root 3. What? You can simplify that? Yes. So, well, first of all, you have to assume that the answer is of the form a plus b root 3. So, we're looking for, I'm sorry, get rid of this radical. We're assuming the answer is going to be a form of the form a plus b root 3. So, if I square this, you should get 52 minus 30 root 3, right? If this is the square root, right? If it's a square root, if you square it, you should get the original. So, multiply out the left side, so you get a squared plus 2ab radical 3 plus 3b squared. That's equal to 52 minus 30 root 3. And then equating. So, a squared plus 3b squared got to equal to 52. And then this radical 3 term got to equal to that radical 3 term. So 2ab got to equal to negative 30. Now, if the numbers are going to come out nice, like this equation, a times b is equal to negative 15, then you can kind of guess and check, right? Like 5 and 3, 5 and negative 3, negative 3 and 5, 1 and negative 15 or something, yeah? So you can guess and check. Otherwise, if it's not nice, then you just have to solve for b in this equation and then plug it in here and solve. But most of the time, in fact, almost every single time on the Math League test, they make it come out to integers, so you can guess and check. So what do you think? And what times what equals negative 15? Harold, let's make a chart. Shall we start with 3 and negative 5? Does that work? If I plug in 3 and negative 5, no. What about negative 5 and 3? 25 plus 27 is equal to 52. See, but the problem with that is it also could be 5 and negative 3, right? Because when you plug it in, you got to square it. So which one is it? So is the answer going to be negative 5 plus 3 root 3, or is it going to be 5 minus 3 root 3? What's the answer going to be? Well, whenever you square root something, you have to get a positive number. So you got to pick the one that's going to be positive. So which one is positive? Well, what's bigger, 3 root 3 or 5? How can you tell which is bigger without a calculator? You square each one. If you square 5, you get 25. If you square this, you get 27. 27 is bigger than 25. So since 3 root 3 is bigger, this is the answer, because the answer has to be positive. So you always got to watch for that. Okay, next event. Relations and functions. Okay, now, in this event, you just have to be able to find domain and range. That's a large percentage of the problems right there. You got to be able to do composition of functions. You got to know what affects the graph, like how do you stretch the graph, shrink the graph, translate it, reflect it over the y-axis. You got to know all that stuff. You got to know odd, even. Look at the notes. Everything is in the notes. Now the tryout problem, here's a tryout problem. Or you got to be able to find inverse. Okay, now, before we even start, it's probably kind of good to just sketch this graph. So the x-intercept is what? Negative 4/3. Y-intercept is 4. No vertical asymptote. Horizontal asymptote is y equals 0. So the graph looks something like this, yeah? So the range is going to, which is a listing of all the y coordinates, is going to be between here and there. So you know the answer has to be between something and something before you even start. Okay, now the procedure for finding domain is to solve for y and look for restrictions on x. Like in this problem, the domain would be all real numbers, because there's no, when you have a fraction, you just got to make sure the denominator is not 0, but it's never 0, right? To find the range, you solve for x and look for restrictions on y. So that's what we need to do, is solve for x. So first step, cross multiply. Okay, and if we're solving for x, we need to put this in quadratic form, because there's an x squared term, an x term, and non-x terms here. So we need to put it in quadratic form like this. So here's the x squared term, the coefficient is y. Here's the x term, bring it over, the coefficient is negative 3. And everything that doesn't have an x in it is y minus 4. Now, if you put this into the quadratic formula, you're going to have a radical, right? And inside the radical is the discriminant. B squared minus 4ac has to be greater than or equal to 0 because it's in the radical. So B squared minus 4ac has to be greater than or equal to 0. You solve this inequality, that will tell you the range. Okay? Now, yeah, okay, I'll go over this after. So how do you solve inequalities? Let's review really quickly. 9 minus 4y squared plus 16y greater than or equal to 0. 4y squared minus 16y minus 9 less than or equal to 0. And then you factor it. So what is that going to be? Is this a 4 or a 2 and a... This is a 2 and a 2 full. 9 and a 1 minus 18 plus 2 will give you the negative 16. So when you make your number line, you get negative half and 9 halves. Yes, yes, plus, minus, plus. And we're looking for less than, so it's right there, which kind of confirms what we see on the graph. So now remember, domain and range are sets. So you have to give set notation. So you either got to write the set of y such that negative half is less than or equal to y is less than or equal to 9 halves. Or you can write interval notation, which is a set already, like this. But sometimes on the answer line, they already have the set there, so you probably want to use that one. Domain and ranges are sets. Okay, now the other thing is, if you use the quadratic formula on this, you know, instead of going straight to the discriminant, you would have negative b plus or minus the square root of this thing here. B squared minus 4a, this is a y, c, all over 2a. And this is what x is, and you might say, oh, but y cannot be 0. But if you look at the graph, y can be 0. Right there, y is 0. So you got to watch out for that. That's why I would highly suggest you draw the graph to help you. Okay, and then the last one is trig. So even if, again, if you're not in this event, it's helpful to know these things. Okay. Okay, so inverse trig function. So the most important thing about this event is make sure you know your ranges. Let's do a quick review, even though it's on the notes. The two ranges for the inverse trig functions are between negative pi over 2 and pi over 2, and then the other one is between 0 and pi, right? So which ones are between negative pi over 2 and pi over 2? That would be sine inverse, cosecant inverse, and tan inverse. And the other three are over here. Cosine inverse, secant inverse, and cotan inverse. These are the ranges. And remember, they're not always going to write sine inverse. They could also write arcsine. They mean the same thing. So for example, if you had something like this, cosine inverse of negative half, you got to be thinking in your head, cosine of what angle is negative half? But the answer has to be in the range. That's why the answer is going to be 2 pi over 3. The range is the key for this event. What about sine inverse negative root 3 over 2? Sine of what angle is negative root 3 over 2, but the answer has to be in that range? Well, the answer is negative pi over 3 then. Okay, and then also in this event, this has been only from last year, solving triangles. So you have to know SOHCAHTOA, law of sines, law of cosines, the ambiguous case, 1/2 AB sine C to compute areas of triangles. Like for example, they could give you a problem like this. Here's a triangle, this side is 3, this side is 4, this angle is arc secant, give me a number, 5. Arc secant 5. What is the area of this triangle? No, I don't like arc secant 5. Let's change it to arc cotangent 2. Yeah, I like that better. Well, the fastest way to find the area of a triangle, if you know two sides and the included angle, is 1/2 AB sine C. And how do you compute the sine of this angle? This is not a known angle, so you draw a triangle, right triangle. Remember, inverse trig functions are angle measurements. Arc cotangent 2 means the cotangent of that angle is 2 over 1, so 2 over 1. Use the Pythagorean theorem. And then the sine of this angle is just opposite over hypotenuse, so it's 1 over root 5. So the answer is going to be 1/2 times 3 times 4 times 1 over root 5, and then you just simplify that. Okay, what if they ask you to find this? Well, if you know two sides and an included angle, you would use the law of cosines, right? So to find the length of this side, you would go x squared is equal to 3 squared plus 4 squared minus 2, 3, 4 cosine of arc cotangent 2. So you draw the triangle again, and the cosine of this angle would be adjacent over hypotenuse. So this is equal to 2 over root 5, and then you can simplify that, yeah? So a lot of things you got to know in this event. And then you also have to be able to solve equations with inverse trig functions in it. So here's the trial problem. Theta equals tan inverse 1/3 plus tan inverse 3/2 plus tan inverse 7/4. So if I add these three angles together, what angle do you get? Well, one way is you can guess, but we're gonna get our answer first, and then we'll confirm it with a picture later. So the normal procedure is you either sine both sides, cosine both sides, or tangent both sides. In this case, obviously you're going to tangent both sides. But before I do that, I would bring one of them over. And it doesn't matter which one. Which one you want to bring over? The tan inverse, what? 1/3? Whatever. And then you got tan inverse 3/2 plus tan inverse 7/4. Then you tangent both sides, like this. Tangent of this, and then tangent of that. So the tangent of gorilla minus banana, you gotta use identities, so you still gotta know your identities. Tangent of the first minus tangent of the second, all over 1 plus tangent of the first, tangent of the second. And same thing here, tangent of gorilla plus banana is tangent of the first plus tangent of the second, all over 1 minus tangent of the first, tangent of the second. So simplifying each one, multiply top and bottom by 3 here, you get 3 tan theta minus 1 is over 3 plus tangent theta. And that's equal to this one, if you multiply top and bottom by 8, you will get 12 plus, we're multiplying by 8, yeah, 14, all over 8 minus 21, which is 26 over negative 13, which is negative 2. Oh, that works out nice. So cross multiply, you get 3 tan theta minus 1 equals negative 6 minus 2 tan theta. 5 tan theta is equal to negative 5. Tangent theta equal negative 1. So if you add these three angles together, I don't know what that angle is, but I know that the tangent of it is negative 1. So is the answer negative pi over 4 because it's in the range? Don't be ridiculous! Each of these angles has a range, but then you got to add them together. So that's why we draw the picture. How do you draw an angle that's tan inverse 1/3? You go opposite over adjacent, make the ratio 1 to 3. That's tan inverse 1/3. Okay, how do you add to that an angle tan inverse 3/2? Well, if you make this 2, well, if you make this 2, then you just need the opposite to be 3. So 2 plus a little bit 3 there. See? So tan inverse 3/2. And then tan inverse 7/4. So if you make this 1, 2, 3, 4, and then you make it 4 plus 3, so that's about 7 over 4. That's this angle. So if you add this angle and that angle and that angle, what does that look like? But the tangent of it is negative 1. 3 pi over 4 is the answer. Okay, so there you go. That's an overview of meet 3. So you guys are given less worksheets now, so let's do a good job on them. JV, we need to kick it up a notch.